Right, this continues our discussion of estimating manufacturing costs. As before, our cost of manufacturing is going to be figured based on the FCI, which is the construction fabrication costs, our operating labor, our raw materials, our waste treatment materials or processes, and our utilities. These various multipliers were derived based on previous work. What we want to do now is look at how we are going to gather that data. So in Chapter 7 we talked about how we can estimate the cost of the actual facilities. And in a previous video we talked about the operating labor. We will be talking about raw materials and waste treatment, but for now let's talk about utilities costs. So, lots of different kinds of utilities that we'll need. Fuel and electricity are the primary ones that people bring to mind. So, fuel, you may need it for a fired heater, for instance. Okay? Now, you'll look at a process flow diagram, and it will tell you how much heat you need, the process load. Okay? Just, you get that from an energy balance. But the total flow you're going to actually require is going to be more closely related to efficiency. Now, that's going to be in a later chapter when we talk about that, when we get into some of those details, but you're going to need to know what the efficiency is of your process, how much energy will actually be converted. Now, you also are going to have to deal with fuel costs, and those are going to vary a lot. We're going to look at a picture here in just a few minutes. We're also going to have electricity costs. Pumps and compressors require electricity. The shaft power is the fluid power, what is actually delivered to the fluid, divided by the efficiency of the pump or compressor. And the power to the drive is the shaft power divided by the drive efficiency. The process flow diagram typically gives shaft power, but make sure that you know before you start doing calculations or you'll end up with mistakes. So those fuel costs, I said that they could vary widely. This is just 1996 to 2009. You can look at this and see how difficult it might be. Okay, this is the CPCI. Okay. Look at the fuel costs, how they changed, but then now they've come back down. So they're not really following all that closely the CEPCI. Okay? Now, there are 6 fuels listed here. Coal is going to be used if you are in a coal region. Okay? It is not cost effective generally to move coal great distances, and so therefore it isn't all that widely used unless you're in an area where they always use coal, and you'll just simply know that. Natural gas is going to be an awesome choice because it's clean, but unfortunately, and it's inexpensive, but it's not used all that often just simply because of the infrastructure that's already in place. Fuel oils are more commonly used. Number 6 fuel oil is a very heavy fuel oil. It's, I don't know, kind of heavy, kind of dirty, but it is going to be used some. Number 2 fuel oil is a much lighter. It's the one that's most commonly used in industry. There are shifts going towards natural gas as natural gas becomes kind of more abundant. With current technologies, it seems like I've seen more and more natural gas usage. But number 2 fuel oil is another very common choice. The others would be related to the location of the plant. Then we also talked about the electrical is going to be related to pump and compressor efficiency. So we have our thermodynamic efficiency, which relates shaft power, okay? But now then we have to relate that to the drive, what's turning the shaft. And if we have an electric drive, our efficiencies will be fairly high typically. But if you have a steam engine or a combustion engine, the efficiencies will go down. And so you'll need to make the appropriate decision based on what your shaft power is and what type of drive to come up with an efficiency. And a graph such as this gives you a good estimate that you can use in your calculations. Now, a lot of our utilities are about heat transfer needs. Steam is one of the biggest, most important utilities in most plants. Now, steam typically is going to be categorized as this is a high-pressure steam line or a low-pressure steam line, and those relate to temperature. Okay? So it's the quality of the steam, not quality as in the thermodynamic, fraction that is vapor, but it's just how good the steam is, how much energy it has. So it's rated typically based on pressure level. So low pressure would be usually like the 30 to 90 psi-ish, medium 150 to 250, high 525 to 680 psi. You'll notice there's a whole lot of regions there that have nothing listed, right? Well, you sort of just need to know for your plant what you're talking about there, what the line is. But these would be reasonable estimates most commonly used. A lot of times your steam will indeed be saturated steam. It'll just be, quality of 1 or very, very near there. But sometimes you're going to have it superheated. Okay? When you have a large chemical facility, back where I used to live, there was a trash-to-energy plant that was right next to a refinery, and they were able to burn trash from the city and convert it to steam that then they were selling to the refinery so that they could operate a lot of their equipment. There's just steam is generated and sold and bartered in a lot of different ways. So a lot of times you're going to be creating steam. Typically high pressure steam is going to be the best way to carry this. And if you have too much of this, you can use it just to create electricity, which can run your pumps and your compressors. Okay? So you can use it to drive them directly, or you can use it to drive and store energy in a generator. Okay? Here are kind of some vague steam requirements for operating various kinds of rotating equipment. Depending on what you need the pressure to be, these are typical steam temperatures, okay, and pressures that you might want to choose. Okay? Most of the time, power plants will provide steam at 250 bar and 1075 degrees Fahrenheit. That's a very typical value today. Now, you're going to have a lot of things where we are heating and cooling things with steam, and a lot of times if we are using steam to heat a processed fluid, it will have condensate that is returned to the system. And we typically do just simply return it and reboil it, okay, trying to conserve our resources there. We're just going to, when we're estimating how much this is, just use the cost of the steam and bring that in. Then when we are generating steam later, we're going to take it as a credit. Okay, so just do it as a cost is a little bit easier as you're analyzing various pieces of equipment. Now you're going to lose some steam in your processes, just various reasons. Sometimes it actually gets mixed into a process fluid. Sometimes it's because leaks, any number of things. The condensate system, when you return it, usually goes to, say, maybe an open pond, which is evaporating out. Various kinds of things will cause some steam to be lost in the meantime. And as I said, if you take your boiler feed water and use that and have a process fluid that is exchanging heat, and so the process fluid is cooled, but steam is generated in the meantime, the easiest thing to do here again is simply take it as a credit. So it's a negative cost for operating the plant, okay, when you're generating steam. That way, by the time you put your total plant cost together, it will all come out. Now, cooling water. Cooling water is going to be very similar, but you're going to have to, unfortunately, with cooling water, you always need to be adding chemicals, treatment, so that you don't end up with, I don't know, algae growing in it, so that it is not corrosive inside your lines and so forth. So you're going to be always having to take your system, and it may be a closed system in one sense, that the water is just circulating through your process, but you're going to have always evaporation and various kinds of losses. And so you're going to have to add some water makeup and some chemical makeup to this. When you're doing estimates for how much your utility needs will be, you're going to be doing it based on what the temperature difference is, okay, in your applications for the cooling water. Okay? The delta T is probably going to be 40 to 30 degrees C. You probably should do a cost on the cooling water based on how much energy is being used. If the cooling water is being returned at 40 degrees or 45 degrees, it's not just that big a difference, okay? Just kind of treat it as all the same kind of cost. When you're doing estimates for how cooling water is used, when it's being used to cool a process, the maximum exit temperature for your cooling water ought to be 45 degrees C. You really should never go above that. And the reason is not that the water is unstable or, that you're at risk of boiling. It's that it's going to have a higher propensity to foul your pipes, which is going to cause more mechanical problems, maintenance problems in the long run. So we're going to be cooling things to, say, 40, 45 degrees, maybe less than that. If that's not going to be adequate, then we're going to use refrigerated water so that we can go colder. Okay? So if you've got refrigerated water, you just need to figure out what the supply temperature is, and that's going to be the big cost. Okay? How cold did I need the water to be when it was going into the cooler? Okay? And that's the cost. It's not how much it comes out at the end. There's a graph in this next slide that's going to show how cost of refrigeration varies with temperature. And really this is done based on what? Coefficient of performance. You remember that from thermo? Okay, so the reciprocal of coefficient of performance is really what we're talking about here in terms of my costs. And the refrigeration temperature. And as the refrigeration temperature gets higher, this cost gets lower, which is totally reasonable. Okay? And then there's some numbers associated with that. Now we need to come up with dollar values, right? The rest of that was just explanation of how they evaluate these things, but we need dollar values. And so there's a table. I have it here in a series of slides. And basically different kinds of utilities that we might have, little sub-descriptions of whether it's, say, high pressure or low pressure steam, cost based on energy, and cost based on the way it's typically sold. Okay? Now, air supply, we didn't actually talk about that, but plants, the legacy control equipment is very frequently going to have pneumatic systems in it. And you may need it to drive a lot of other systems. So you will have a high pressure air supply. Okay? Whatever air supply you need, it's not really providing energy. You're just needing to provide so much volume of air. And so these are your cost values based on volume. For steam from your boilers, you're going to, again, have to decide which pressure category they're in, and then you can either price it based on energy or in terms of how many kilograms of steam, which is a common way of doing it. For high pressure, come down here, we end up with the higher energy steam. We're going to take credits for that at 1233 per gigajoule. Cooling water, other kinds of water, if I'm using it for a process or whether I'm using it for boiler feed water, remember that's going to have to be treated. If I'm using drinking water, do I need DI water? And then electricity, I'm going to have an electrical distribution system within my plant. And so the relative cost of that and the various fuels. And these were all based on, I believe, $2,009. I think it says at the end. We'll check on that. Refrigeration, thermal systems, so if I'm using, fired heaters or whatever. And then waste disposal. Now we're going to talk about waste disposal as a second category later, but those are in the same table. So the cost, you'll see, cost of dealing with something that's not hazardous but I still have to get rid of is low. Cost of dealing with hazardous things, incredibly high. And then wastewater. And it does not tell me what the year for this was. I believe it was 2009, just like previous table had been. So at this point, I'm going to close this video. In the next video, we'll start looking at some examples because in order to estimate utility costs, these tables here help me come up with a dollar amount, but to figure out how much energy, I'm going to have to go back and do a little bit of refresher from my thermodynamics and heat transfer courses. Okay, so that concludes this video.